Hi, everyone, and welcome to this session about progressive delivery at Intuit, the next chapter in the GitOps journey. My name is Henrik Blixt, and I'm a principal product manager for platform and open source.
And my name is Jesse Suen, and I am a principal software engineer at Intuit and maintainer of the Argo project.
And just quickly, before we get started, just a brief note on who we are. So Intuit is a US-based financial technology software company founded in 1983 here in California. And already from the start was focused around software called Quicken, a personal finance management application. And we've continued to build financial software for the last few decades. And we now have a number of applications. For those of you in the US, you're probably most familiar with TurboTax, the financial tax preparation software. We also have a personal finance application called Mint and a small business accounting program called QuickBooks. So across these applications and these segments, we have tens of millions of users. And with this age and legacy and size, we started encountering some challenges. So we had a lot of data centers, and we spent a lot of time managing our data centers, managing the hardware, setting things up, configuring things, and being a financial technology company, that's definitely not part of our core business. They're not solving any business case other than delivering compute. We also had some inconsistent software development lifecycle processes and secure software development lifecycle processes. We didn't really know what was being used where. If there was security vulnerabilities, and if there were some, it took a long time to remediate. And there was just a lot of various things being built and used across the company. One of our business unit had 29 different tools to manage their life cycle, for example. And there were a lot of complicated integrations, scripting, and just a lot of snowflake things going on to get things to run. And this also led to a lot of unreliable and complex and unrepeatable deployment processes. Engineers just spend way too much time doing things other than writing code. So for example, it could take 15 weeks to create a new application because they had to provision environments, make sure ports were open on the firewalls, and just worry about a lot of other things that were not innovating, writing software, deploying their applications. So this just led to our engineers solving the wrong problems, not focusing on the core business value, delivering the core business value. A lot of frustration because they want to innovate, they want to move fast, but they were bogged down by some of these legacy things. And the outdated tech we had meant that had to work with old versions, old software, and everyone wants to work on the latest, shiniest thing, right? And our engineers were very reactive instead of innovating. So we started a process and a journey to increase our developer velocity. There was a study by McKinsey here some time ago that showed that the top quartile developer velocity companies have a revenue growth that's 4 to 5 times larger than those in the bottom quartile. So it kind of spurred this transition and modernization. And some of the key areas we focused on was operational excellence, making sure that we can have the observability, we can see what's going on, understand what's going on, and introduce the right amount of processes that doesn't burden engineering with bureaucracy, but still have enough rigor to keep things in line and know what we're doing, and make sure that we can move faster while still lowering our mean time to detect and mean time to resolve issues that occur. All these various tools that we had before also means there was a lot of various ways of solving things. And we realized we didn't have a platform, we had many platforms. So we needed to standardize the APIs, standardize tools, leverage standard capabilities as much as humanly possible, and then introduce self-service and automation, to the full extent that we could. And in this, also improving the development experience, modernizing the tools and the technology, make sure it can take advantage of all the new innovations in the tooling area, and letting our engineers work on the latest and coolest technology where it makes sense. And also making sure that all the innovation and all the work we do, all the services we have, making sure that everything is easy to discover, easy to search, easy to find, so components can be reused and reused to further increase the velocity that we move at. So this led us down a paved road, which is the internal name we have for some of the guided paths for engineers to do things like deploying service mesh, Lambda, and especially a grouping of best practices, automation, and script to help them standardize things and get things deployed in a standardized way. And this journey started back in late 2017, 2018, and then has led us in the last little bit over 3 years now, and has also led us to introduce applications like Argo CD and Argo Rollouts that Jesse will talk about later. That were things that we discovered during this process, that there wasn't really anything that fulfilled in the tooling that we could find. So we started this journey of building some of the tools we needed ourselves as well. And this journey has led us down a path of automating all the things, using GitOps, using DevOps. If you build it, you run it, making sure that engineering take responsibility for everything from writing the code, testing, until it actually gets deployed in production. Operationalizing everything. We have an operational data lake where we dump all our operational data, making sure that we can track things, trace things. We run a lot of queries and dashboard against this data lake around development productivity, statuses, migration statuses, if things go wrong, to make sure that we can have a good eye on what's going on and lower those MTTR and MTDDs for our applications and services. We also simplified a lot of things, which allowed the engineering teams to focus on their core competencies, focusing on solving the business problems, innovating, releasing applications that help our customers solve their business needs, and also enabling them to move faster. They don't have to worry about all the minute details on how a pipeline gets created. They can just have it done for them. That lets them focus their energy on the things that they want to focus on. And lastly, modernizing our platform, shifting everything to using cloud-native technologies, using Kubernetes, and lately using things like Service Mesh and Lambda, and transitioning all our engineering teams to adopting that and being comfortable with that was also a big change. And using things like GitOps and DevOps in this whole process, to make things more automated and move smoother through the software development lifecycle. And now I'll hand it over to Jesse to give some more details on the progressive delivery part of this platform.
Thanks, Henrik. So at Intuit, we have a developer portal, which you can see a screenshot on the left. And the developer portal is a one-stop shop for creating and administrating services at Intuit. So after onboarding a web service, the developer will get 3 Git repositories. One is their application source code repo, which is by default is this hello world of some Spring Boot application. They'll get a Git repository containing application config, and we use Spring Cloud config to hold application config. And most interesting for this talk is their deployment repository, which contains Kubernetes manifest. And we currently use Customize for managing configuration. In addition to that, they will get a container repository for their service. They'll get a Jenkins CI pipeline, and the pipeline is actually what promotes that application between environments. They'll get a set of Kubernetes namespaces, and the namespace corresponds to an environment. Typically, they'll get a QA, a stage, a prod west, a prod east. And then finally, they'll get an Argo CD project and a set of applications tied to this service. So right away after onboarding, service owner will be able to start developing their code, and with their next commit, they can actually start deploying to multiple environments and exposing it to their clients. And when I talk about environment promotion, what I mean by that is that the developers have these handful of environments, these QA, EDE, stage, prod, and they need to first deploy their changes to QA, run some tests. If that goes well, they go to stage, repeat that, and then go to prod. And this is all driven by that Jenkins CI pipeline. And so that CI pipeline has the ability to take a commit from master all the way to production. And what it's actually doing is it first builds that container image, and when it is time to deploy to an environment, it actually commits that image tag back to that deploy repository. And then Argo CD will go and sync that change to the namespace. And what you see here is a screenshot of one pipeline, the tail end of a pipeline that had just deployed to stage, ran tests, got approval to go to prod, and then ultimately deployed to production. So now let's talk about progressive delivery, or what actually happens inside a single environment, and how we do safe deploys during an update. So if you don't know what progressive delivery is a practice where you are incrementally exposing new versions of your application to initially small subset of your users, and then gradually larger and larger subsets. And the reason you do this is you want to limit the number of users who might have been negatively impacted by a problematic version of your software. And chances are you might already be doing some form of progressive delivery already. You might just not have known there was a term for it. And examples of this is canarying, where you're doing a traffic split between the canary and the old version. Feature flags, where you build dormant features into the application, and you just turn on those features on and off to various customers. And ring deployments, which is a fancy way of just organizing your deployments into larger and larger rings of users. For example, your initial ring might be internal users, and then you deploy to your alpha users and beta and early adopters, and then finally the rest of your user base. So the way we do progressive delivery at Intuit is through a project that we started called Argo Rollouts. And Argo Rollouts is a progressive delivery operator. It's a controller that runs in a cluster. And it's designed to be a drop-in replacement for the deployment object, but with these added functionalities. So let's walk through what Rollouts offers. So first, as you are probably aware, the deployment strategies in the basic Kubernetes deployment are really basic. You have rolling update, but rolling update is limited in that, one, it can't do an atomic cutover to that new version, like you can with blue-green. So your service better not require something like API consistency to its clients. Two, it can't stop and pause in the middle of the update, since a rolling update is trying to get you from version 1 to version 2 as fast as possible. The second set of features Argo Rollouts provides is that it integrates with ingress controllers and service meshes. And it does this to do more advanced traffic shaping, things like percentage-based traffic split, header-based traffic split, or even shadow trafficking. And finally, Argo Rollouts can integrate with metric providers such as Prometheus and Wavefront, Datadog. And it does this in order to be able to analyze how an update is going. And if it's going well, either continue with that update, or if it starts failing metrics, then it can abort and go back to that previous version. So let's see how this actually works in practice. And I'll be showing you what happens when a rollout is updated. So just like a deployment, a rollout creates and manages replica sets, one for each revision. Here we have a rollout which is at a steady state. It's currently deployed at revision 1. But also notice that we have two services which point to the stable and canary replica set respectively. In this case, it's at a steady state, so they're both pointing to revision 1. And then we have an ingress object that is splitting traffic between the two services. But right now, it's 100% to what we marked as the stable replica set. So as soon as a user makes a change to their rollout pod spec, Argo Rollouts will create a new replica set using that new pod spec. And then it starts scaling that up gradually. And the rollout will also then modify the ingress and tell it to start splitting traffic between the canary and stable versions. Here, it just bumped up the percentage to 5%. So next, the rollout wants to start evaluating how the update is going, and it'll start performing analysis of that canary by querying some metric provider. In this example, the rollout is querying Prometheus, and it's querying the HTTP success rate of that query. If that measurement is successful, the rollout continues on with the update by then scaling up the canary stack and then increasing its the weight to the canary. And it just continues to repeat this process or according to whatever steps you define in the rollout until it reaches 100%. And then once we reach the end of the steps, the update is considered complete and the new revision is promoted as the stable, and we start sending, we mark it as stable and send 100% traffic to stable. But what happens when in the event that the measurement fails? So let's say Prometheus came back with the HTTP success rate that was below our threshold. And in this case, the rollout will then abort that update, flip the traffic switch 100% back to our stable version and mark that second revision and scale it down as unhealthy. So as I mentioned, Argo Rollouts integrates with a number of different service meshes and ingress controllers, including all of the ones you see here. And that's really made it very flexible for our developers, even at Intuit, where we actually run, they have several options of ingress to services. And so now I'll pass it back to Henrik, who can describe how this has improved our release velocity.
Thanks, Jesse. And just to show you some numbers on where we are today. So we currently have about 11,000 applications on this platform, running on almost 400 Kubernetes clusters across 15,500 nodes here in the public cloud. And we can see here the number of applications over time as we've onboarded more applications to the platform and also increased our release velocity, how the growth keeps accelerating. And we can see here currently we're month to date, we're about 0.5 in release velocity, which basically means that each engineer releases half an application per week. And we can see that maybe a little bit too small, but we have about 1,500 releases or so to prod per week, and 7,000 to 8,000 or thereabouts releases to pre-prod. So there's a lot of activity going on, and we can see the growth getting accelerated both by people onboarding onto the platform and our velocity increasing. And what are the other values that we've seen with this GitOps and progressive delivery? We've seen how we've empowered engineering. Things are moving a lot faster. Things that used to take weeks now takes minutes. And to create an application is done through the self-service platform in minutes. Sets everything up automatically. Everything is cloud native. bleeding edge technology. People get to move on the latest technology where it makes sense. And we're using the value that's out there in the community and out there in the market. We've also seen our release velocity that I talked about and improved 3 to 4 times. Our cycle and deployment times also see big improvements, in 5x improvements here. And on the operational side, with our data lake and all the new data, standardized data we get from all these applications, we've seen an improvements of 5 to 10 times in our time to find issues and to resolve them. And lastly, but not least, given all the time that was spent by engineering before in things around deploying an application or releasing an application rather than writing code, we're now saving around 1 million developer hours annually with these new processes and through this journey. But we're not done yet. In the upcoming year here, our fiscal year ends here in July. So for next fiscal year, we're looking at doing a large-scale analysis-based rollout, like Jesse mentioned earlier, making sure that we can take what we have and increase the velocity even further, making sure that our applications can figure out if they're healthy or not and take remediation automatically. And we're looking at how we can increase that analysis intelligence even further by utilizing AI and using rules engines to figure out whether these applications are healthy or not, and helping us get progressive delivery to the next level. And that next level, we're targeting to get to an increased velocity of 1, making sure and enabling our engineers basically releasing 1 version, 1 release per week. And with that, I thank you all for tuning in, and we'll see you here shortly for live Q&A. Thank you, everyone.
Hello. Thanks for coming to the talk. So now we'll start answering questions. So first question I see is, what did we use to build our developer portal? And that one is actually, that was completely homegrown. So I think it has a Java tech stack and databases and stuff. But I did want to mention that Spotify has open source developer portal called Backstage. I personally haven't checked it out, but it's actually quite similar to what it's trying to accomplish as to our in-house developer portal.
So I'm going to do, so the next one I think here is, how did y'all convince your product organization to allocate budget for increasing dev velocity? I think the key question and the key point is convincing your product organization that developer velocity is important. Once you've reached that goal and your management and the executives actually understand why developer velocity is important, then getting to the next point of getting the budget to increasing that discussion is a lot easier.
All right, and then next question is, how does Intuit utilize Argo CD or paved for GitOps for Lambdas? So actually, we have a separate tool that we use for AWS cloud resources, which is actually based on CloudFormation templates. And Argo CD is purely used for Kubernetes deployments. There is an open source project that Amazon runs called ACK, which stands for AWS Controllers for Kubernetes. And it basically lets you manage AWS resources using Kubernetes style manifests. And that's an option for people who like to use Kubernetes as their control plane. All right, next I see, how does Rollouts compare with Spinnaker? So that's a good question. Actually, a closer analogy is actually Argo CD versus Spinnaker. So Intuit actually migrated from Spinnaker to Argo CD because both of those are deployment tools. One is Argo CD just focused on the GitOps deployment tool specifically for Kubernetes, and Spinnaker is more general purpose. And Rollouts actually can integrate with Spinnaker. In fact, one of our users, Salesforce, I think they contributed some kind of Spinnaker plugin or something that lets you use rollouts with Spinnaker.
I can see noted. How does Intuit utilize Argo CD or a paved road for GitOps for Lambdas? So we currently have a separate GitOps tool, which is based on CloudFormation. Oh, did you answer that one?
Yeah.
Oh, sorry.
Okay, so how does Argo support DB migrations that are sometimes required? So as a best practice, this is true for developer services. Intuit recommends that our developer teams perform database migrations out of band separately from the deployment process, and also in a backwards compatible way. So for example, you should add columns, but you should never remove the column until you're certain that it's no longer used. And this should also happen out of band from your regular deployment, so that you can roll back let's say your deployment without having to go through another database migration.
And do you all ever sunset applications? Yes, we do, but the rate of additions and increases in applications and services is much faster than we can ever sunset. So, and as the company is growing, our services are growing. It just the rate of new applications just keeps growing.
This is a good question. So what is the rationale behind numerous repos per application? Does that generate repo sprawl? Has it been intentional to not use a repo approach? So keep in mind, at Intuit, we have like 4,000 developers, I think. Maybe it might be more than that. And so it was important for us to have a lot of self-service capability. So the idea is that a developer, it's actually a repo per service, and they have multiple environments for that service. But the idea is that they should be able to self-service themselves if they decide they need 2 ingresses or they need like many more deployments. They should be able to do that and not go through pull requests to some kind of centralized mono repo. And that's the motivation why we have so many repositories.
I think that was the questions I see in the chat and the QA.
It says, do we have GitOps-based governance around releasing to production? So that pipeline that I showed you in the slides, if you look closely, the one that I highlighted was actually, there's an approval step that happens in the Jenkins pipeline. And so what needs to happen is to go to prod, a developer has to visit the Jenkins pipeline, and they click on an approval step there. Once that happens, the pipeline actually commits to the production customized directory, and then that's what actually takes it to prod. Okay, so if there was a follow-up on the repo question, so Stan did not mean to imply a global repo, but per service. Why not merge runtime development? Oh, I see. Okay, so why did we give 3 repos? So there was an application source code repo, a Kubernetes deployment repo, and a Spring Cloud config repo. I think one of the answers is a technical limitation. I believe Spring Cloud config, I've been told that it kind of wants the whole repo. So automatically you need 2, one for your source and one for your Spring Cloud. Then the deployment one is necessary because if it lives with your app code, then you have this kind of chicken and egg problem where like our pipeline wants to commit back to the deployment repo, but also that could trigger a Jenkins build. And so you either have to account for that in your Jenkins pipeline, or you separate out the repos. But the other reason you want to separate your repos is that oftentimes the people who can affect the environment should not be the same developers who can make source code changes. And that's not true for Intuit. Like the same, we practice DevOps, but that's one reason why you might want to separate out the repos, just because of privilege. Okay, I think we have
And I think
1 minute
we have
left.
yeah, so a few seconds left maybe. How many developers in Intuit use the platform framework? I think it's somewhere between 4 and 5,000, probably close to 5,000 by now. And I think with that, I think we're out of time. So thanks everyone for tuning in. And if you have any questions, you have our Twitter handle, so feel free to reach out and we'll do our best to help you out. Thanks everyone.
Thank you.